Yo, what's up, guys? Welcome back. I think today is like 103, 104. I think it's 104, maybe. I don't know. 103. We got an executor today. Let's take a look. There's our sound. But yeah, let's take a look at a quote for today to get us going. Where motivational?
Was nominated to do the USC Speak Your Mind.
Yeah, sorry. So our quote of the day here. Let's just do. Don't let yesterday take up too much of today. There we go. Just a simple one there. Pretty much telling you, you had a bad day maybe yesterday. Just it's a new day and keep going. So that's kind of what we're gonna do. Don't let yesterday take up too much of today by Will Rogers. I don't know who that is. An American performer and actor. Cool. All right, well, let's take a look at problem of the day. Count complete subarrays in an array. Have we done this one? No. Okay, we'll take a look at this one first. You're given an array nums consisting of positive integers. We'll call a subarray an array complete if the following condition is satisfied. The number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. We call a subarray an array of complete. We call a subarray of an array complete if the following condition is satisfied. The number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. The number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. So would this be the subarray here? Okay. So I think this is probably going to be... Man, I feel so weird today. I just feel a little off for some reason. I don't know why. But yeah, let's take a look. I'm going to actually turn on the air conditioning really quick. Oh, shit. Microphone's not working, dude. There we go. Okay. Holy shit, dude. The bouquet would be $135. Oh my god. Jeez, man, $135 for flowers, bro. Oh my gosh, dude, it's insane. The array consists of only the integer 5, so any subarray is complete. 5 to... Why is it 10? I know this is a recursive problem. Like, sliding window... How do we calculate every single subarray? Well, I'm trying to think here. It says sliding window. How can we do this using sliding window? I don't understand. Since the constraint's small, you can check every subarray. It gets TLE. If recursive, we want to pass in I think we want to pass in our index, right? Okay, if our greater than the length of nums minus 1, we would just return, right? Man, how the hell would we do this? sliding window template. Just standard sliding window question with brute forceable constraint, but throw TLE and brute force approach. How would this be a sliding window? Would we start here, do every single number? If it gets to the end, we go to the next number, and then move the left pointer here. So be 1, 2, 3, 4. 1, 2, 3. 1, 2, 1. Maybe that is sliding window. Alright, in range, length, nums. Guess we have to figure out how many distinct nums. How many distinct nums? Alright, so we have to go, okay, for I in range, length nums, we can check, okay, well, we can create like a set. Actually is equal to set. Hashy.add set. Then we grab distinct is equal to the length of hashy. Okay, so we have our left. Let's actually print our distinct right here. An indent in the for statement. Expected and indented. Bro, my stomach like hurts hella bad, bro. I don't know. What is going on here, dude? That's because of that. Oh my god, hashy.add. And find nums. Okay, we got 3, right? So we know that our distinct is 3. Okay, so we can do okay. Well, for right in range length nums, right? We have our left pointer. Left is equal to 0. Okay. For right in range like nums, we can check, okay, well, starting window we need fuck, man, I'm thinking we're gonna need some sort of hash map now, like Okay. We want to add the right to our hash map, right? So my_dictionary dictionary. Dictionary right plus or equal to 1. Maybe we can use a default dic. Don't have to worry about the... How do we import a default dictionary? Default dictionary. Python. Okay, right. We get the default dictionary. How do we make a default dictionary? Okay. I should be able to get this, bro. Like 75%, like surely. Especially if it's like a default sliding window approach. Maybe not a default dictionary, right? Because default dictionary has everything set to 0. So maybe it should just be a normal dictionary, right? We add the value. My_dictionary right. Let's do, sorry, num's right, because now we're adding the index. Not in my dictionary. Then my_dictionary num's right is equal to 1. Else, if it is, then it's my_dictionary num's right plus or equal to 1, right? So we loop through, do that. Okay, we have... We need some sort of if statement, right? Like, okay, well, if -dictionary, if the length of -dictionary is equal to distinct, right? Then we can increment by 1, right? The length of it is equal to distinct, right? Then we know that it's a complete subarray, right? So we can add it by 1. If it's not, equal to distinct, we can increment by 1, right? Count plus or equal to 1. If right. Else if it's greater, right? If the length of my dictionary is greater than distinct, then we're gonna need to do something, right? We're gonna need to This is wrong, bro. There's no way that this is such a stupid solution. Like, in Python, does length of the dictionary return number of keys? Is that what?
For the USC Speaker Mind Challenge, I nominate Sami Canavan, Jay Gagné, Reba Real, Abby Kosick, and Sean Diddy Combs. You have 20 minutes. Oh, shit!
The length of dictionary count plus or equal to 1. If the length of the dictionary is greater than distinct, I think we're gonna need some sort of while loop in here, but you know what? We're just gonna do, okay, well, if it's greater than distinct, let's take a look at a sliding window template, dude. I'm tripping on this, dude. Okay, we probably need some sort of while here. While the length of my dictionary is greater than distinct, right? Then we gotta remove our first value, right? So we gotta do, okay, well, delete. We have to check, okay, if minus score dic left nums left is greater than 1, right, then we just have to do minus score dick nums left minus equal to 1. Nums left minus equal to 1, right? Else, if it's 1, right? I don't know if we're going to get a null pointer here, but maybe we can do is equal to 1. We can delete, otherwise we just decrease it, right? We can just delete the entry, right? Delete minus score dick nums left, right? Okay. Now we do left plus or equal to 1. Okay. Bro, I hate working with a dictionary, dude. Oh my gosh, dude. Okay. Otherwise, down here we want to add right? Minus score dictionary. Let's do add right. Okay, minus score dictionary. Nums right plus equal to 1. Okay. It's greater. We delete it, right? But now we have to figure out, okay, well, what if we get to the end, right? If we get to the end of the array, end of array, if right is equal to the length of my dictionary, it's pissing me off, dude. There's no way the code is this long, bro. Like, oh my god. Man, today's not a good day, bro. A little frustrated. frustrated. Okay, I didn't realize that you could just... man, how did I not realize that? Distinct is equal to the length of set of nums. Instead of making that stupid for loop, right? We can do it like this, clean that up. That means we can get rid of the hashy set. We can just initialize the dictionary. We obviously need a count variable. We totally forgot about that as well. We need the count variable. Count is equal to 0. Count. Let's go to is equal to default dictionary. Int, right? Do for right. Okay. Frequency nums right plus or equal to 1. See, I thought about a default dictionary. It gets rid of this, you know, stuff right here. Underscore dic. Nums right plus or equal to 1, right? Now we check, okay, while the length of the frequency is equal to... I did it the opposite way. So while the length of my dictionary is equal to distinct, right? So this is a valid subarray. What do we want to do, right? We want to increment our count. Okay, that's the first thing we want to do. We want to how can we do it if we're finding valid subarrays? Well, do we just want to keep adding? All subarrays starting from left to right are valid. Count plus equal to n minus right.
Nominated by Abby for the USC Speak Your Mind Challenge. I want to nominate Jaws, Brooke Gapart, and Tisha. Alright, my name's Anthony Cody. I was nominated by Kevin Ortiz in the USC Icebook Challenge. Yeah.
Whole subarray starting from left, so we take the length of nums and then we minus it from where we're at. We take the length of nums, so we got 4. The length of my dictionary is equal to distinct. We increment the count. So equal to the length of nums minus right. But that's all the numbers from the right side, isn't it? Like, man, I got so much going on, bro. I'm like,
And Jeff and Uncle for nominating me for the USC Speak Your Mind Challenge. I would like to nominate Aljon Reed, Ian Stuckey, and Tony Struble. 24 hours.
man, my head is everywhere right now. Literally, like, all over the place. I think today's just not a good day, bro, honestly. Like, okay, I'm gonna figure out the brute force for this, man. This is really, like, I just don't think I'm in the right mindset right now to do this. Like, it's just that sort of day, I think. We generate every single subarray in this array, right? So we go here, here. We probably want to create a distinct, right? So we know distinct is equal to the length of the set of nums, right? We loop through, okay, we check, okay. For left in range length nums. For I, J, right? How do we keep track of this, right? So distinct. Can I not even spell today either? Distinct. Yeah, that's what I thought. Okay. You want to go 0, 1, 2, 3, 4. Okay, we need like a count array, right? Okay, we need some sort of like, we need the length here too. Length of nums. We need to check, okay, if the length of... Maybe we need some sort of set here, like curve set is equal to set. If the length of the curve set is equal to the length of distinct, then we want to increment, right? So we would increment our count plus or equal to 1. We want to have our set each time we have I, so we can start from the beginning, but is it like a... Three, 1, 2. 3, 1, 2, 2. Okay, I think this should work. Then we just increment curve set dot add I, and then we can return our count. There's no length. The length of, oh, sorry, distinct. Sorry, we want to add J. Expected 5, output 4, expected 10, output 5. We're resetting every time. We're adding. The length of the code set is equal to distinct. We return the count. Maybe we want to go from I every time. Is that what we're missing? J is equal to distinct. Curve plus or equal to 1. The output is 4, the expected is 10. Why are we getting 4? For this one, we should get 4, but then we go to the next I. We start from I, we count that number. We should get way more than... It should go 1, 2, 3, 4, then move the I, reset the set. 1, 2, 3, 7, 8, 9, and then reset and go to 10. Why is this not... Bro, I have no idea, bro. Literally, like... No idea. Bro. Oh my god. I'm not adding the value, I'm adding the index, bruh. Oh, bro. Why did that take me 50 minutes to solve? I didn't even see... Bro. Let's do the recursive solution. Alright, let's do... Okay, well, def recursive. I'm gonna pass in an index. Probably our count too, right? Our base case would be, okay, well... Some sort of base case, right? I believe we loop through with the index, so for I in range... For index in range length nums, we would just want to... Probably want to initialize a new set every time, so cosset is equal to set, right? We'd loop through with the index, and then we'd add each number. So we'd go, okay, cosset dot add nums index. Okay, let me check. Okay, if cosset, if the length of cosset is equal to the length of cosset is equal to distinct, then we can do cosset dot add. Sorry, we increment our count. That's what I'm... Plus equal to 1, right? And we would return... Recursive index plus 1 count. I guess the base case would be, okay, well, if the index is greater than length of nums minus 1, then we would return, right? We'd stop our stuff. Maybe we don't even need to pass in our count, right? We're not even calling our function, so recursive, and we pass in 0 as our index, right? Can we do non-local count? We start from index, I guess, right? Let's do I. There we go. I mean, that wasn't any faster, but can we pass in instead of, would it work? We just passing in our count. Right, yeah, so it wouldn't work with passing in count because we actually return back the original copy. Yeah, interesting. I knew that wouldn't work. That's why we use the non-local, because I didn't think it would save, right? Non-local count. Get rid of this. Okay, now the sliding window approach. Oh, we go back to the sliding window approach. Well, we need a left pointer. For right in range length nums. We need, okay, well, if the length of minus core dictionary is equal to the length of, sorry, is equal to distinct, right? Then we just simply add our count, right? Plus equal to 1. Okay. We need to add right first. So minus core dictionary, nums right, plus equal to 1. Can you do this without a default dictionary, bro? Like, are people using... Okay, what's the hash? Importing default dictionary. Why the default dictionary for write, val, and enumerate nums? default dictionary int increment while the length of my dictionary, we increment the count by 1. I don't understand why this line. Like, I don't get this line. I don't understand this, right? Then we go, okay, well, my dictionary, num's right. Minus equal to 1. If minus score dictionary, num's left, equal to 0, we can delete my dictionary, num's left, right? Otherwise, it's meant to be left, right? We delete it, we can increment the left by 1, return the count. But why, like, when we see something that's distinct, right? While the dictionary is distinct, count plus or equal to length minus length of nums minus right, and then we decrement the 1. If my nums left is equal to 0, we increment by 1. I just don't understand, bro. Like, I can't think of it this way, bro. It's like too out of the box for me. Oh. So we get to here, we find 1. Then we know that everything else after this is also a subarray. Ah, so then we know 1, 3, 1, 2 here. So nums are right is... Oh, okay, I think I'm understanding, right? So we get here. So we're at 0, 1, 2, 3, 4, 5. Right, or technically... Yeah, so we're getting 5 minus right, right? In this case, our right is 0, 1, 2, 3, right? So then we get 2, right? We get our count would be 2, right? Because everything after this is also a thinger, right? Then we delete left and we go to here, right? Okay, so now we're here and we check, okay, well, 3, 1, 2, right? And everything after that is 4 as well. And bro, what an interesting way to think about it. I could not wrap my head around that. I was like, why are we grabbing the next string numbers? Now I understand. That's the optimization. Okay. See, look, to be honest, like, I really wasn't feeling good at the beginning of this video. I was actually like, I actually feel kind of sick right now in my stomach. So I don't think if I was fully normal, I think I would have solved that problem in a sliding window format, because I wouldn't have realized that optimization right there. I think maybe I would have got the, the n squared probably a lot quicker, or the brute force a lot quicker, but I don't know. Definitely an interesting line of code. I'm just not feeling good right now. I don't know what it is, but I'm like, I think I'm gonna take a nap maybe. Just really not feeling good. I do want to do one more problem before I go. Yeah, it's shorter day today, but you know, I don't want to finish like that. I want to finish on a good problem. All these DP and these bit manipulation, dude. Oh my god. Let's take a look at some of the greedy or something. Valid parentheses. I think I've done this one. I think this is a stack problem, isn't it? You can. Let's just do this one. I'm pretty sure I've done this one. Might get us a little bit thinking about a stack again. Oh no, I have not solved this one. Given a string S containing 3 types of characters, bracket, close bracket, and star, return true if S is valid. The following define a valid string. Any left parenthesis must have a corresponding right parenthesis. Any right parenthesis must have a corresponding left parenthesis. It's got a 38% acceptance rate, jeez. Left parenthesis must go before the corresponding right parenthesis. I don't really get this. Left parentheses must go before the corresponding right parentheses. Okay, so if we see a left, then we have to... It's a backtracking problem? A stack problem. That's what I thought. We're going to kind of try and solve this using a stack. So let's do stack here. So no one cares about the star, right? Given a string S containing only 3 types, right? Return true if S is valid. No, we don't care about a star. I think a star can go literally anywhere. Like, I don't want to read that. We go for I in range length S, right? So guess we'd have to append to our stack straight away, right? So we'd append nums I, right? Guess if nums I is equal to we probably need to open P is equal to 0, closing P is equal to 0. Right, so if we were to see, we would do open P plus or equal to 1, right? We'd append to our stack. Okay. Stack dot append nums I, right? How are we going to use a stack here, right? We're keeping track of the... So a star can be treated as anything. Okay, I don't know how I didn't read this line here. Can be treated as a right parenthesis, or single left parenthesis, or an empty string. How can we go about this problem? We have a stack. Okay, so maybe we can use our stack to keep track of our stars. Well, that sounds stupid. We're not really... Maybe we can use our stack to keep track of our brackets, right? Okay. So like... Man, now it's cold in here, bro. What the hell is going on right now? Okay, so let's say we have test case, this, and this, right? We loop through, we keep track of our brackets, right? So our stack keeps track of our bracket, right? And we keep track, okay, if our stack has this and we see this, right, then we can just pop both, right? Okay, then we keep going, we see this, and we have a star, right? We have one star left, then this is technically valid, right? That's what I'm thinking, but I don't know if that's the best way to use the stack, right? So say, okay, well, if then we would do stack dot append nums I, right? Right. Else if nums I is equal to this, and stack minus 1 is equal to this, then we would stack dot pop. We would just stack dot pop. That removes both of them, right? Okay. Okay, right. So then we can do, well, else if, right? If nums I is equal to this, and our stack is none, right? Let's do and not stack. Then we can, I guess, just append, right? Stack dot append nums I. right? Else, if we see a star, right? Because the left parenthesis must go before the corresponding right parenthesis. If we see that, we append. If we see this and we see that, then we can pop, right? Else, I think my solution is wrong, but I mean, I don't know. Else, if we see a star, but could we have a case where we could have a case though where it shouldn't be the empty stack, it should be where stack minus 1 does not equal C, right? Because we could keep adding rights, right? Because it must have a corresponding left, right? Any left parenthesis must have a corresponding right. Left parentheses must go before the corresponding right parentheses, right? So we should have one more, right, where, okay, else if nums I is equal to this, but the stack, right? We should probably split this up, right? We'll probably split this up, right? So we can split it up. Okay, well, if stack, right, then we can do stuff if there's something in the stack, okay? Else, if it's not stack, right, the stack's empty, we can append, right? If the stack has something in it, right, so that means it's either got to have a parenthesis, a closing parenthesis, so I guess if stack minus 1 is equal to C, is equal to, okay, if nums I is equal to this, right? And stack minus 1 is equal to C, right? It won't work, right? Because here we have, okay, well, if we have the left parentheses must go before the corresponding right parentheses, right? So if we have a right first and then so if nums I is equal to this, but then the stack is that, then we can instantly return false here, right? We know that it's false, according to this statement here, right? Okay, because any right parentheses must have a corresponding left parentheses, right? Because if we see that, right, then we instantly know that it's false, okay? So if our nums I is equal to nums I is equal to this, and our stack minus 1 is equal to stack minus 1 is equal to this, right? Then we can just stack.pop, right? We can just remove it because it breaks, kind of cuts them off, right? Else, right, if we have nothing in our stack, right, then if stack is equal to this, we would append, right? Then we would pop, right? Then if the nums I is equal to open bracket, right, then we would just append, right? But if it's else if nums I is equal to this and it's empty, we can still append, right? Nums I, right? Okay. We're gonna need some sort of star, right? Let's do stars is equal to 0, right? We loop through, okay? We need an else if right here. Else, right? If it's a star, okay, we just increase the star by 1, right? Star plus or equal to 1, right? Over here, we would do, okay, else star plus or equal to 1, right? Otherwise, right, we get through everything, okay? We get through this loop, right? Then we have to check, well, if the length of stack, okay, if not stack, we can return true, okay? Okay, wait. If the length of stack, or we can take the length of stack, let's do, what's the best way we can do this? I'm trying to think, well, if not stack, right? If the stack is empty, then we can just return true, right? Else if it's not, okay, if there's something in the stack, then we have to check, well, what's in the stack, right? So we would have to, okay, if the length of stack if the length of stack is equal to stars, right? Because stars can be either, we will return true. Else, if it's not, we would instantly return false, right? I believe, let's see what that does. Oh my god, dude, there's so many noms, dude. Is there anything else? Oh, we did it. Oh, shit. Man, how am I meant to debug this, bro? Like, with this test case, like, how am I meant to debug this? Like, bro, I can't even count how many parentheses there are. it says here that you're not handling star flexibly. You just count stars and compare against leftover stack at the end. This isn't sufficient. The core logic of matching parentheses using the stack is a bit off. You're not distinguishing between star that could balance this. The greedy approach, we maintain low, minimum number of open left parentheses possible, high, maximum number of open left parentheses possible. What I do here, they go for Einstein and you write S. If char is equal to this, they append. If char is equal to this, stack.append. Else, char is equal to this. If open stack. Try to match remaining bracket with star acting. Man, I really thought this was correct. I guess I'm not using star properly, right? Maintain. There goes my solution, bro. OpenStack, star stack, right? So they create 2 stacks. Okay, we can get rid of these. For I. Why do they use I in here? For I in S, right? Char is equal to this, right? Then OpenStack dot append I, right? Also, if char is equal to this, char is equal to star, we append the star. Star stack dot append I, right? Else, if it's this, if it's a closing bracket, then if stack, if OpenStack, then stack.pop, right? If star stack, then stack.pop. Also, if star stack, stack.pop, else return false, right? Otherwise, check well, OpenStack and star stack. So while there's stuff in it, in OpenStack and star stack, then we check the top value is less than I don't understand this right here. Oh, wait. Okay. I and char in enumerate S. Now I think I understand. Okay. Using the enumerate here because we're checking the char. Okay, char, else. Right, we're checking the char. But here we're actually appending the index. Right? So while OpenStack and star stack, right? If OpenStack -1 is less than star stack, right? Because star must come after. Okay, if OpenStack -1 is less than star stack -1, then OpenStack.pop, star stack.pop. Also, I guess we return false. Get through this while. Turn true. Stack is not defined. Oh shit. If OpenStack dot pop start stack dot pop. So instead of returning true, we have to check if return not OpenStack, right? Because if this is true, right? Turn not OpenStack. Okay, so not OpenStack would be I thought I could understand it, but not OpenStack. Not OpenStack is if it's okay, right? If the length of OpenStack is equal to 0, you return true, else return false. That's probably better. Interesting. All right, we're going to call there for today. I appreciate you guys watching, and I will see you tomorrow.